This is lesson 85, VHDL example 56. And in this example, we'll write a top-level VHDL program that will load the switched data into a register. We'll use these four components that we've seen in previous examples. Here's our clock div and our X7 seg BC that we had in lesson 80. Here's the clock pulse module that we designed in lesson 75. And this is the n-bit register which we designed in lesson 70. So we're just going to put these together in this top-level design. The clock div will bring out clock 190, that is 190 Hertz pulse. We'll use that to drive our clock pulse component as well as X7 seg BC. Remember, the 50 megahertz M clock is the input to here. We'll use button 3 to clear all of these modules. We'll use button 0 as the input. So when we press button 0, we'll get a single clock pulse out of clock pulse, and we'll call this output clock P. Then the switches will have the 8 switches coming into this register D, and the output Q is going to get displayed on the 7-segment display. We'll display the switches on the LEDs. Now the load input to the register will use button 2. So when you press button 2, the load signal goes high. Only then, if you push button 0, will you get a clock pulse, and then the switches coming in D only go to Q, remember, when load is high on the rising edge of the clock. So this will test how this register, 8-bit register, works. Well, all we have to do is make a top-level design and port map all these components together. So we've got M clock coming in, button, we'll put 3 down to 0, all the buttons, the 8 switches, the 8 LEDs for the output, and the A to G and AN and decimal point for our 7-segment display. So in the architecture, we'll list the components: clock div, clock pulse, these are our component declarations, reg, that was our n-bit generic register, input D, output Q, and the X7 seg BC component. So then in the architecture, we'll need a signal Q and a signal X. Q will be 7 down to 0, 8-bit number, X 16-bit number, 15 down to 0. And we'll also need signals for clear, clock 190, and clock P for the clock pulse. Clear is button 3. X is going to be Q, and we'll pre-pen some zeros here to make it a 16-bit X, which is 15 down to 0. Switches get connected to LD. Here's our port map for clock div. Just connect the M clocks. The output's going to be clock 190. Here's the port map for clock pulse. Button 0 is going to be the input. C clock is our low frequency clock 190. And the output's clock P. Here is the port map for the register. We'll make it an 8-bit register. Button 2 is going to go to load. Clock pulse goes to clock. The switches get connected to D. The output goes to the signal Q. Then X7 seg, X to X, which has this Q, you remember, pre-pended with the zeros. C clock is the clock 190, and then the rest just get connected. So you can press button 0 all you want, generating clock pulses. Nothing will change on the 7-segment display until you press button 2. When you press button 2, load goes high, and then the switch settings connected to D will get latched into Q, and that result will then get displayed on the 7-segment display. So you should download this top-level design into your board and check it out.